The next theorem we're going to talk about is called the rational zero theorem, or sometimes it's called the rational root theorem. This is from section 2.5. We're not going to do all of this section, but just parts of it. The rational zero theorem says it gives you all the possible rational roots of a polynomial equation. Not every number will be a zero of the function, but every zero will be in the list. Okay, so the possible rational zeros of a polynomial function can be found by taking the factors of your constant term and dividing it by the factors of the leading coefficient. Okay, so if I look at my first example here, it just says use the rational zero theorem to list all possible rational zeros for the given function. Okay, so I would look at the factors of my constant. Okay, so what are the factors of 14? 1, 2, 7, or 14. But also I have to consider positive or negative 1 will divide into 14. Positive or negative 2. Positive or negative 7. Positive or negative 14. Okay, those are all the factors of 14. And I'm going to divide that by the factors of my leading coefficient, okay, which is a 1. So this one's not too bad because the only factors of 1 are just plus or minus 1. And so when I generate my list, if I had more than one number in the denominator, I would have to write each number on the numerator over each number in the denominator. So for this problem, my possible real roots would be plus or minus 1, plus or minus 2, plus or minus 7, and plus or minus 14. Okay, and so this is one problem like you'll have on the homework. They just want the possible roots. Now, like it says, not every one of these numbers is actually a root or a solution, but your solution is given here. You could find what those are by using synthetic division. Okay, and that's what you'll have to do on number 8. It says find a rational zero and use it to find all the zeros of the function. Okay, so I'm going to use the rational zero theorem. The factors of 6 could be plus or minus 1, plus or minus 2, plus or minus 3, or plus or minus 6 over the leading term, which is a 1 again, so that's just plus or minus 1. So my possible roots would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So I'm just going to start testing them by synthetic division, and I'm going to start with 1. Okay, if I use positive 1, I'm going to see if I get a remainder of 0. So I could do synthetic division. 1, that would be 1, 3. Okay, if I don't get a remainder of 0, then that means this is not my root. Okay, so then I may try negative 1. So that would be negative 1, which would be negative 6, positive 6. I get a remainder of 0, so that means negative 1 is my root. Okay, so now I can use this and the polynomial that I get here, which is x squared plus x minus 6, to solve this polynomial function. Okay, so I'm going to take x cubed plus 2x squared minus 5x minus 6 to solve it, and now I know that I can break it down into x minus a negative 1. Okay, so this is actually going to be x plus 1 and x squared plus x minus 6. And so now I can factor. This is going to factor as x plus 3 and x minus 2. Set each one equal to 0. And so I have my 3 roots. x equals -1, x equals -3, and x equals +2. So if I compare this to my list, all of those numbers are in this list. Okay, so those are my possible roots, but these are the actual roots to the polynomial function.